Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host, Rich Gear, here as well, and we're going to revisit a subject we have not talked about in quite many a moon, Doug. It's brings you back to happy memories of your first book.
Right. This is, really what got me started down this road, and the subject is animals which could not have evolved.
Yeah.
I guess I remember hearing a preacher way back in the time, and the thing that really got me was he said something about the problem with whales evolving from mammals would be that you'd have to start with a creature that lived on the land and went back into the sea.
But first, after he was in the sea to start with, right, and got on land, and then decided he didn't like it, wanted to go back to the sea after many hundreds of thousands of years, or however long the time sequence is. So yeah,
he asked one question, and this one really stuck with me. As he asked the question, well, how did the whale's nose go from the front to the back of his head?
Right.
And I got to thinking about that, and there's a principle that I really then started me investigating, that there's too many codependent entities within the creature. If you make a change, it's got to actually work, with all the different entities in order for it to make a change into a different environment.
This is sort of a variation on that theme of irreducible complexity. In a sense, we're not dealing at the genomic level, but even on the biological realm, we have so many, even interdependent creatures, that one creature is living off of another creature for it to survive. And how does that work? I mean, how do they I was thinking about the fish that hang around the shark. I mean, how do they not hang around the shark without getting eaten? You know what I'm saying? There's certain things, and they clean the teeth of the shark. But even goes down to you got this creature, and we'll maybe get into that later on. I don't know, whenever you decide you want to get into that mitochondria, or there's some weird thing where it's a little bump of a bacteria or something. I did the drawing for it many years ago, and it fascinated the heck out of me. There's this microscopic creature, and then within the microscopic creature, there's a microscopic creature. It's just, I don't know. Maybe you can explain it better.
Since you're on that subject, which is way down my notes here.
It's way down the list, but it fascinated me, Doug, because at the very basic small levels, this is happening.
It was called Mixotricha paradoxa.
See, I know.
It was an organism that lived in the guts of Australian termites.
Think about it.
And it's actually something that is part of what digests the wood as the termites eat it.
Is that right? Okay.
And so this little organism, microorganism, is a creature. It's like a big bacillus. Bacillus is sort of like just a blobby type of organism, but it's got all these little bumps on it. And, in these bumps are burrowed these spirochetes. And the spirochetes are spiral-shaped creatures that actually their locomotion.
They move the thing in there.
Well, it's actually going into this bump and pushing the bacillus, and then there's also the foreflagellum on them that normally is what that is used to steer the organism as well. And so you have these different.
It's like you got a creature within a creature within a creature. It's like it's really amazing to me, and how things like that would have evolved makes no sense at all to me.
Right.
It makes no sense at all from any kind of level. There are other creatures that are more. You talk about like the tongue of a giraffe, for instance, or something like that, or you talk about the whale and the nostril back of the head. So let's get into some of those. That creature.
Well, I'm going to go back to the beginning.
Okay.
And,
I want to start at the small level and then go build up. So.
But what I researched this stuff probably from around 1968 on.
Right.
When I was still in high school. I was realizing that evolution wasn't really making sense, especially with the experiments I was doing, origin of life. I was investigating that.
You want to list them, Doug, and maybe then talk about each one individually?
No, I want to talk about my old books.
You want to talk about your old books? Oh, man.
Well,
okay, fine.
I'll take you. It started out with this one, and this is a book, Revolution Against Evolution, which I wrote about 1986. This is the first version, and the second version looks like this. And I gave this copy to my grandmother, and she passed away in 1992, so I got it back, but I thought I saved that one. But I wrote about all these creatures in this book, and the question I asked myself just yesterday was, how well are these old arguments holding up?
Okay.
And I got to looking at them, and they're actually holding up pretty good. Arguments I made over 30 years ago.
Paley's Blind Watchmaker still holds up today, no matter what Richard Dawkins tries to say. It still holds up. That Blind Watchmaker is a devastating argument for evolution, I think. And anyway, so it doesn't surprise me that the 30-year-old thing that you would have written in your book still would hold up. It's nice though when you see that, though, isn't it?
It is, and that also shows that whenever you have something that's true, you're not going to change the truth by arguing it. Yeah.
Okay.
And so I talked about in my book, first of all, dolphins and whales.
All right.
I also talked about the duck-billed platypus and the koala. And it's not a koala bear like I had in the book. I got corrected on that.
Oh, yeah?
They just call it a koala. Then there's birds.
It looks like a bear, though.
Like the woodpecker, the hummingbird, and the water weasel, and a few other birds that are pretty unique. Anglerfish, archerfish, anableps, and decoy fish.
Oh, yeah, I love those.
And then I also talked a little bit about the frog. And actually, that's a fairly significant piece of that chapter, because there was a lot of detail in that part of it. And then you have things like the origin of flight, and you have flight appearing 4 different times. But with
what do they call it? Convergent evolution.
Yeah.
Which is just a nice. That's when I first got on the idea that scientists don't always know what they're talking about, but if they put a label on it, it sounds like they do.
Right. Yeah.
Because the idea that flight would have evolved 4 separate times: reptile, birds, mammal with the bats, and insects.
Right. Yeah.
And totally different mechanisms.
And then you have wannabes like flying fish.
Flying squirrels, that kind of stuff. But there are the bats. There were the reptiles, which as far as we know, they're all extinct. Although there's possibility that maybe there's one laying around. But then of course the insects we know about, and then the birds. But 4 different ways.
It's interesting. I'm part of a Facebook discussion page where they're investigating all the reports of pterosaurs all over the world.
I love that. I just wish somebody would capture one if they're really around. I want them to get one.
I'm keeping my eye on that group, but I haven't been really participating because I'm not.
Oh, you're doing trolling?
I'm trolling in that area. I'm hoping that somebody actually finds them. I know there's John Pendleton down in Mexico, who's a missionary down there, who keeps saying that they're seeing them all the time down there. And
how come nobody can get one then?
Yeah.
To me, that's like aliens, man. You know what I mean? It's like, they're there, and well, I just saw them over here. It's like. And I'm kind of a little suspicious, let's put it that way, But I really would love to see one happen. I mean, it would be remarkable to see a living pterosaur. We've talked about the roe pen down in Papua New Guinea.
Papua New Guinea, that's the same thing.
And then the ones down in the Mexico. You talked about one years ago up in the northwestern part of the United States. They supposedly saw something.
Well, on this page, they're seeing them all over the United States. So it's not just.
Yeah, we have no photographs. no eggs.
Well, they've got video footage of them and things like that, but they're way off in the distance. It's like watching the condors.
Sorry, that's not going to convince anybody. Even people who want to believe like me, it's not going to convince me. So you got to have a healthy dose of skepticism, even though you're willing. I like the Berean attitude, Doug. When Paul commended the Bereans, because they listened and they were eager to hear what Paul had to say, but then they went home and searched the scriptures to see if the things were true. And that's what we have to do, even as creationists. We have to see it, hope, and we'd love to see it, but we got to basically see if these things are really true. It has to hold up in the court of evidential science, you know.
I'm going to pull out my old book, okay?
All right.
Now, if you want to see the third edition, I had the first edition and the second edition here, and I've only got a few copies left. I've got 2 of these and 3 of these old ones. But there is a part of the chapter on animals that prove creation. There is a fairly detailed write-up that I lifted out the Creation Research Society Quarterly, and it was by a fellow by the name of Gerald Duffett. And he talked about his linkological evaluation of the frog.
Okay.
And the frog, a fairly common creature, we know all about it. But there's a whole bunch of characteristics about the frog that he went and linked together and said if you didn't have this, you wouldn't have that.
Okay.
And so here's a list of entities that he had. It talked about air and tiny lungs, no trachea, no neck, undifferentiated vertebrae, no thorax, no abdomen, no diaphragm, no ribs, pectoral girdle shields heart and absorbs shock. There's no rib muscles. There's a urostyle, which I got to figure out what that is.
A urostyle.
Hind leg
font. That's what I know, but that's not what this guy's talking about.
Yeah, hind legs for leaping. There's no larynx. There's glottal epithelial flaps, vocal pouches. And the croak, a single ventricle, atria receives oxygenated blood, the cutaneous respiration, the amplexus, the forelimbs, a highly vascular skin, mucus, nubital pads on the males, poikilothermy, which is cold-blooded, hibernation, low ambient temperature, webbed feet, pond water, external fertilization, gamete release, identification of opposite sex, no external auditory apparatus, tympanic membrane on the head surface, no air underwater, no need for a secondary palate, the nostril closes and vomerine teeth on the roof of the mouth, eyeballs are retractable to aid swallowing. So these are all features of the frog. Now, we probably hadn't thought that all these different details of the frog are much different than the other creatures. But this is very interesting. And what he does, he links the numbers to each other. And you have air and tiny lungs linked together. Air being less dense than water would not allow a frog to dive for cover if the lungs were not small.
Okay.
So he links the air to number 20, which is cutaneous respiration. The air diffuses through the skin to enter the blood capillaries.
Oh, is that right? Okay.
Then you have number 2 and 3. This is tiny lungs and no trachea. The tiny lungs are not only too puny to have a reinforced windpipe leading to them, but they're subsidiary to the skin. And so these are design features unique to the frog.
What does that mean they're subsidiary to the skin?
In other words, the air diffuses through the skin.
Oh, okay. All right. That's what I thought. Okay.
And then 2 and 19, tiny lungs and atria receives oxygenated blood. The atria receive blood equally oxygenated because the skin is as efficient as the respiratory surface as the tiny lungs.
Oh, okay. All right. So that's why I can jump in the water and,
right.
and escape. Okay.
The number 2 and 30, with the tiny lungs in pond water, the much greater density of water compared with air prevents the frog from carrying large lung prevents the frog from carrying a large lungful pond surface to pond bottom. Now they have no trachea and no neck. There's no point in having a neck if no trachea is present. And then number 8, no diaphragm. And number 6, no thorax. No diaphragm is, you have no diaphragm, so no boundary and trunk to separate thorax from abdomen. Therefore, you don't need a thorax. Number 8 and number 7, no abdomen, no diaphragm. No diaphragm, so no boundary and trunk to separate the thorax from abdomen. Therefore, you don't need an abdomen. Okay.
I never thought about all this with a frog, you know?
Yeah. Have hind legs for leaping, and the pectoral girdle, you see, after jumping with the hind limbs, the pectoral girdle absorbs shock of landing on hard ground.
Doug, I want to ask you, maybe you don't have this thing, I always come up with a question you might have, how about toads? Are they similar, or is it the same thing, or I mean, obviously toads and frogs are different, but they're very similar in that as a hind leg and the way they look.
Right. A lot of the things would apply to toads as well.
Okay, all right.
The difference between toads and frogs are just, I think, the texture of the skin, pretty much.
Yeah, I don't know. Yeah, one kind of lives more in the water, one's more on the ground. That's what I was. But yeah, it's kind of a different thing. But anyway, all right. So
and because you have no larynx, the eyeballs are retractable to aid swallowing. It means that swallowing must therefore be performed by muscles pulling eyeballs into the head to push the food into the esophagus. Skin respiration causes blood leaving skin to be oxygenated as blood leaves the tiny lungs.
So does the frog get all of his oxygen in his tiny lungs, or does he absorb oxygen through the skin as well as releasing
both,
it?
yeah.
So he does both. Okay. All right.
Then skin respiration is possible because that organ is richly supplied with blood vessels. Oxygen dissolved in water can diffuse into skin both when the frog is in the pond and when the frog is on dry land, provided that the skin remains moist. And so really what's happening here is you're having all these different factors making what an amphibian is supposed to be.
Okay. How does that relate to, well, I mean, obviously there are things about frogs, the hind legs, for instance, that are different, let's say, from a salamander. But a salamander is an amphibian. Does it have some of the similar characteristics as a frog? Like the permeable skin or small lungs or not? Probably not.
Probably not, no.
Yeah. So it's kind of a unique amphibian in that regard.
Frogs would become deaf if water entered their ear holes, so they have no external auditory meatus on their heads. No eye socket bones and no secondary palate allow the eyeballs to be retracted by muscles and so help push the food into the esophagus.
Yeah, you read that too. So.
And so it shows that there was a thorough systems analysis that took place when God designed the frog. It's sort of like when you're an engineer and you're trying to design something. You can show that the one system can't exist without the other system being in place. It's sort of like unless you have a computer, you can't build an operating system. And unless you have an operating system, you can't have a database.
I know, but I gotta tell you, years ago, I went and saw Richard Dawkins at Michigan State University, and a bunch of kids came with me. Mm-hmm. And he spent the whole time showing why an airplane wing was designed, why a bird wing wasn't. And of course the group that was sponsored was the Atheist Club or whatever, and they're all congratulating each other how smart I go. And then the people who were with me were pretty intimidated to listen because Dawkins is this big high muckety muck in the evolutionary, he's supposed to be a smart guy. And I said, well, what did you think? And he goes, that was not impressive at all. What he said didn't make any sense at all, even on the face of it. It's like so much of the stuff, Doug, is like the Emperor's New Clothes. When you read, I mean, we may have belabored the point with the frog. Maybe audience wasn't expecting a big biology lesson, but the idea is how complex even a simple frog is. You see frogs every day. Well, not every day. We don't see them in the winter, but I'm up here in Michigan. But I'm saying the thing is the complexity of even something as basic as a frog. But we've talked how complex everything even is down to the molecular level and the cellular level. It just never stops being complicated. Everything is complicated. We talked. That's why I'm glad we talked to that mitochondrial or whatever that I never could pronounce it. But the very smallest things, even to the cellular level, are complex to a way that just screams designer.
And it's interesting. It's like there's all this redundancy. This is something I learned at North Carolina State University, the conference that we went to.
Oh yeah, okay.
Was that there's so much redundancy built into life, where if you actually block out one of the genes, it still functions.
There's a way to.
So there's another gene over here that takes over that function. They block that one out. Well, there's another one, and then another one, and another one, and another one. Yeah, and it just goes on and on. They tried to kill this organism, and they can't kill it.
Really? Yeah.
Because they keep knocking out these genes, and they still function.
I don't know why that surprises. Why, unless you had your head buried in the sand, every computer operator knows they have backup systems. Every engineer creates usually machines that have a default mechanism, or if something goes wrong, there's a way to make it start up again or whatever. And why would we expect anything as complicated as a living organism to not have backup systems? We started talking about that years ago, Doug, when they were talking about all that junk DNA. And then we began to realize the junk DNA wasn't junk. It actually
was full of information.
Yeah,
information we're finding out
to help you do things. Yeah.
And what they're finding out also with the new science that's cropping up is the epigenetics.
Yeah, that's fascinating.
You have a genome where you have these little switches on them that turn it on or turn it off based upon what they. And a lot of it's environmentally controlled.
Isn't it something?
It is really something. Now, I've also brought another book here. This is a book I'm going to highly recommend. It's called Replacing Darwin. It's a New Origin of Species. And the author is Nathaniel Jeanson. And I remember he was at a conference in Ann Arbor just a couple of years ago, and I had lunch with him.
Oh, yeah.
And he and Jerry Bergman and few others, we had lunch together, and he was talking about this book, and one thing that he's going into great detail here is about the variability within the genome. And when God created the genome, and in the beginning, there's all these different varieties that can come out of one genetic kind, and then it spreads to the different things. And he talked about in here about horse series, and I looked up horse series on the Wikipedia.
The famous or infamous horse series.
And, you have Eohippus, Mesohippus, Myrhippus, and Pliohippus, and Nequus. And they have it all in a ascension like this. But down the bottom it said, don't take this as a linear model here.
Oh yeah.
And so they show it as a linear model, but in the fine print down below, it tells and you can find these fossils, like in South America. I guess they go backwards, and what they want to show.
Yes.
And so the horse series has been discredited. But he talks about things like the zebra, the zonkey, the zorse, the quagga.
You talk about the z-donk?
The z-donk, yeah, that's what it is. And then there's Przewalski's horse, the onager, and the kyang.
I don't know those. What are
The
those?
onager and the, no, there's a couple of good Scrabble words here, onager and kayang. Okay.
Wow.
But they're Asian donkeys.
Oh, really?
And they actually look pretty much the same, but genetically behind the scenes, they're not, they're quite a bit
They
different.
don't look, okay.
And so it's interesting as to what it is that you have isolation of certain genetic information where they are inbred and then they produce these breeds. And so we need to think of things like breeds versus species.
Oh, yeah. Interesting, because everybody who breeds horses or dogs or cats for the show, they call them breeds. So,
Right.
so he thinks you should use that term instead of species, huh?
Right.
Interesting.
Then he talked about antelope varieties, and we saw a lot of them out in South Africa, like the kudu, the impala, the
Right.
bonky buck, the springbuck, the duiker. And then there's one that's extinct called the blue buck. And they're actually trying to, and what I talked about was the quagga, that's a zebra relative, and they're trying to bring that back because that's extinct.
Oh, that's
in real
extinct
life,
too? Yeah, okay.
So, a recommended book, I think we'll do a show on that someday when I get it completely read.
Yeah, it sounds fascinating.
But there's a lot of information in that. It's Replacing Darwin, The New Origin of Species.
Okay.
So we'll see you next time on Revolution Against Evolution.